Welcome to this evening's TI Technology webinar hosted by Texas Instruments, where we will take a look at what is a great task and how can TI Technology help your students explore these tasks. I see that many of you are joining us for the first time, so we'd like to offer a special welcome if this is your first T-Cubed Professional Development webinar. We'd also like to thank everyone for completing the live survey on the right side of your screen. My name is Mike Houston, and I'm the moderator for this event. I teach algebra and calculus near Pittsburgh, where I use TI Technology to make tough-to-teach, tough-to-learn concepts accessible to all my students. I'm very happy to introduce our two panelists for tonight, Jennifer Wilson and Connie Schrock. Jennifer is in her 19th year of teaching mathematics at Northwest Rankin High School, where she uses TI-Nspire CAS and the TI-Nspire Navigator system every day to both teach her students and learn from them. She enjoys running mathematics curricula using technology and working with educators to incorporate good questioning techniques, engaging problems, and formative assessment in their classrooms. Thanks for being with us, Jennifer.
I'm looking forward to it, Mike. Thank you.
And Connie taught high school mathematics and is currently a professor of mathematics at Emporia State University. She teaches a variety of undergraduate and graduate classes, but has primary responsibility with mathematics education students, teaching middle and secondary mathematics methods, and supervising student teaching for mathematics. Connie is currently NCSM's first vice president, newly promoted, and was one of the authors of the Great Tasks for Mathematics Engaging Activities for Effective Instruction and Assessment that integrate the content and practice of the Common Core State Standards for Mathematics. Thanks for joining us, Connie.
Hi, I'm excited about this evening.
We're expecting a large crowd, so your audio is muted. Feel free to send questions to all panelists using the Q&A window on the right side of your screen. Throughout the webinar, our panelists will also be engaging you with some questions, and you'll be responding in the chat window. This session is being recorded, and as a reminder, we'll provide a link to the event certificate of attendance at the conclusion of the webinar. Once the recording is available, if you'd like to follow along with your handheld or software, and we really hope you will, we recommend doing this with the recording so you can download the activities and pause and rewind the recording as necessary. We don't expect to have any audio issues tonight, but in the event that you do, try selecting Communicate in the WebEx menu, choose Audio Broadcast, and then click Join. At this point, Connie is going to discuss our agenda.
Hi. We just have a quick overview so you'll know what to expect this evening. Briefly, we're going to define a great task, let you know where you can find a few more sample tasks, and the great task books. Then the majority of our time will be spent exploring 3 tasks that are listed here and some of the student work to go with those. Jennifer's going to tell you about our outcomes.
Thanks so much.
By the end of our hour together, we want you to be able to say the following. I can find and implement good tasks to use with my students that incorporate both content standards and math practices. I can explain the role that technology plays in deepening student understanding of the content.
Thanks, Jennifer.
So I am going to share my desktop, and we will get started.
And as a reminder, now that Jennifer is sharing her desktop, the chat and the Q&A windows, which you just had on the right side of your screen, they're now underneath that green floating toolbar. So if you want to use the chat window to engage with Jennifer or Connie, please feel free to do so. Also, the Q&A window is hiding underneath that little eject button-looking icon underneath that green tab. Jennifer, it's all yours.
All right. Connie's going to get us started.
So we wanted to define a mathematical task, and too often we forget that one of the most important things a teacher can do in the classroom is to provide mathematical tasks for our students. Tasks provide the opportunity for students to uses of mathematics and become interested in important mathematical ideas. When we began our project, we thought about what a task was as we began to define what a great task is. Dick Seitz, Lori Boswell, and I started the project for NCSM, and we wanted to define exactly what we believed a great task to be. Then as the 3 years of the project progressed, the writing team of Kit Norris, Dick Seitz, David Pugley, and Fred Hollingshead continued to create tasks that tried to stay true to this definition. We wanted interesting problems. We want it to be open so they can approach it in different ways. The mathematics should be essential, and we tried to stay true to the definition through the Common Core. They need to have examination and perseverance, and need to be challenged by the task. We want it to allow for discussion in the classroom and to build student understanding, and of course, have opportunities for looking back and with extensions. So that was our goal for each one of the great tasks that we created. Now, we're going to go to the NCSM website and show you where you can find these tasks. Now, this is on, the website is www.methodleadership.org, and Great Tasks is right across, as you can see on the second line there. And when you go down, there are links to, there are two books. One is a K-5 book, one is a 612 book, which is what we're focusing on here, and there's pictures of those books. And if you're interested, NCSM is, we did this as a service project, so NCSM is making the profit on the books, and you can contact them to get it. We also have 3 samples at the top, and none of those samples are ones we're using in the webinar tonight, so there are 3 more you can look at. Odd or even is one of them we were going to talk about, and this is a middle-level task which has applications for the calculators as well. They each follow the same format. We have an overview. We list the standards themselves because, you know, just putting a number down there is difficult for teachers to know what to expect, and we thought, you know, a lot of states aren't using the Common Core standards, but they have standards, and you can look at what this standard says. We also wanted to focus on the mathematical practices. We felt like most every one of our tasks did number 1, which is problem solving and perseverance, so we limited our use of it and tried to pick others, and I'll talk about this a little bit more as we go through. We discussed the tasks. So this is the teacher page you're seeing right here, which has supplies, the core activity, the launch, and extensions, and we're going to go into this a little more as well. Then we get to a launch activity. This one deals with fractions and spinners because the task itself involves a spinner, and many times students haven't had those experiences, so we kind of go through it and then end up with the next, after there's 2 pages on this launch, and then we end up with the task itself. And in this task, the students will do some writing to explain their solutions. And then, of course, the last part of every one of our tasks is some student work so that you can see what we found. Every time we wrote a task, we sent it out across the states, different places, to have teachers use it and give us feedback. And sometimes we modified and made changes based on that. And we looked at what students still needed to know and how we could reform our launches to be helpful. I'm going to turn it back to Jennifer and move on a little bit with the slides.
So as you can see, there were just a few sample tasks on the NCSM website. We're going to be looking at 3 other tasks tonight from the 612 Great Tasks book. And you'll be able to download PDFs of the tasks that we use at the end of the webinar. They'll be included in the webinar files for tonight. But we want to learn from you as well before we look at another task. We have a question for you to answer in the Q&A, and we are wondering where else you find good tasks to use with your students. Hopefully some of you are already familiar with the Great Tasks book, but where else, on what other sites, what sites do you use, or in what publications? I have a few places that I always look, and later in the webinar, if those haven't come up, then I'll be sure to include those. But it's kind of nice to be able to learn from each other and find out, you know, where other people are looking, so we can all have more resources. So,
and if actually you could use the chat window as opposed to the Q&A, it would be a little bit easier. That way everyone could see the responses coming in.
Oh, I'm so sorry. Okay, great. Thank you, Mike.
That's okay. We've already gotten some really great responses from Kevin. He uses NCTM Illuminations and the TI website. And Ruth uses Illustrative Math. And Kathy looks like you. Sorry, go ahead.
Oh, no, that's good. Illustrative Mathematics that is the first place that I go. If I'm looking for a particular standard, a task that goes with a particular standard, I usually look there just because it's so easy to see how they're linked together, and I found some really good tasks there.
We've had a couple from Mathematics Vision Project and Engage New York.
And I saw NCTM come through. All
yeah,
right,
we're getting a lot of NCTMs.
Yeah, thank you for sharing those, and you can continue doing so because those of you who, you know, as you listen, you can look in the chat and get some resources from some others. So we're going to look now specifically at a task called YouTube Views, and Connie is going to introduce us to this task.
So we're going to go back through the format again. We tried to maintain consistency between both books, and we start with an overview that's very brief and a brief description of prerequisite understandings. What do your students need to know how to do before they attack this problem? We made the decision to write out these standards so it would be clear and it wouldn't be unnecessary to look them up, as I said before. And then one of the things we started with when we listed the mathematical practices was just to say we thought it was 2 and 3 and wrote down the practice. And then as we worked with teachers and we explored what we were doing a little bit more, we decided it would be important for us to share with you where do we see students doing this task. In many of these tasks, we could make a case for all 8 practices, but it's not reasonable to try to focus on all 8 practices at once in every task that you do. So we decided to limit it to 2 or 3 in this area. And we kept perseverance and problem solving out because we felt like it fit into all of the tasks. At least that was our goal. When we get down to the bottom of the teacher page, again, we try to point out what supplies we think you're going to need, what the core activity is about, and the launch. And, of course, this is where we list the extensions. And then because of partnership with Texas Instruments, and they were beneficial in creating the book, getting it published, and doing some of the editing when it went to press, we also have additional resources listed and some calculator pages that go along with our work from Texas Instruments. The launch are designed to provide teachers with an activity or activities. In the elementary books, there are more than one that help students review skills needed to be successful at the task. Teachers can use them or not. It's up to them, but it's there in case they want to make sure that some of these skills are covered and attended to and that the students will be able to access the task itself. The task can be used in multiple ways. It can be used as a performance task, a formative assessment. You can use it as group work or as an introduction to a subject or just an application that you find interesting. So we tried to give you as many different ways of using the tasks as we could. The next component then is the activity itself, and there are multiple questions that go with most of the tasks. We're going to explore the first part of this right now, and I'm going to turn it back to Jennifer to ask the question, who won the competition?
All right, we're going to make this a little bit bigger for you so that you can see what the students saw. But the students were given a table, and there was the competition of which video is going to win. And so we see the student names, we see the number of views of the video, the number of days that the video was posted, and the length of the video. So I'm going to pause for about 15 seconds, which is kind of scary to do on a webinar because I can't see your faces. But I want to give you just 15 seconds to just glance at the data and begin to think how you might formulate or analyze this data to formulate a decision about who won the competition. So just a couple of seconds for you to look at that data. So as you can imagine, probably imagine, there were most of the students, when they saw this information, thought about graphing it. Some of them graphed it with using kind of one variable statistics, and some of them did some scatter plots with two variables. So we're going to go to the TI-Nspire SmartView software right now, and in the list editor, I'm going to press the stat button so that you can see the list editor. I've actually already entered the data there, so you didn't have to just wait for me to type that information in. In list 1, we have the number of views for each video. In list 2, the number of days posted. And in list 3, we have the length of the video in seconds, I believe. And so we will set up a scatter plot, and we're going to look at some of the graphs that the students did. So the first graph scatter plot that we will set up will be the number of views versus the number of days posted. So I'm going to go to the stat plot menu, and I'm going to turn this plot, turn it on. You can see I've already got in the X list for the independent variable. We're going to look at the number of views. That was in list 1. And, excuse me, the number of days posted was in list 2. So that's list 2, number of days posted. And then in list 1, we had the number of views. So we'll look at that scatter plot. One of the things that I did think that I would do, some of you might use 84s with your students and use the 84 SmartView. The view we have here can be changed under View and View Cubed options. And so since we're doing scatter plots, I'm going to change this first view to the list view so I can actually see the numbers in my list. And I'm going to change this second view to the stat plot, just so I can see for sure how my stat plot is set up. Since we're focused on the statistics graphing, I think that could be helpful for us. And so before we look at the scatter plot, I am going to use the Zoom Stat window, which will set up a nice view for us. And so again, what we have here is the number of views versus the days posted. And so who might you say won according to that graph? Which one of those points might be the winning graph? As the students looked at it, they decided that the person in the top left should probably be that winner. And the person in the top left was Frankie. So we're going to look at one other scatter plot. This time, we're going to look at the number of views versus the length of the video. So I'm going to go back to my stat plot, and I'm going to change the X list. I'm going to change that independent variable to the length of the video. And I had that in list 3. Just 200, 180, those were the number of seconds of the video. And so now we'll look at a scatter plot of that. And again, you know, some of the language that you saw in the student work was there was a negative correlation here. We had a graph, if we were to connect this with a graph, it would be decreasing. And so again, we can trace to consider, you know, which point is which. And the point, again, in the top left corner was Frankie. So one of the really nice things about the Great Tasks book is that it does include some student work for you to think about how students might respond to this, for you to anticipate how students might respond before you give it to your own students. And so this is a response from one student. There's another one in the book as well, and you'll have that on the PDF that you get at the end of the webinar. And so this student concluded that Frankie won the competition on both graphs. His video was top. And then they got into some of the other questions that we're not going to get into tonight. But a really nice addition, I think, is that student work, so you can have some idea of how this is going to play out with your own students before you do it.
So as we look at this, now this is a different format. It has the practices, and it looks at the practices as they fit together. It's from Bill McCollum's site, and we just rewrote it a little bit. But if you look at 1 and 6, they seem to pertain to all the problems in different formats. And then we have 2 and 3 grouped, 4 and 5, and 7 and 8. So in the chat, which one of these mathematical practices do you think students would have the opportunity to use or demonstrate during this activity? So I'm seeing some numbers there. And
yep, we're getting like 3 and 4 from Julie, 4 and 5 from Kathy, another 4 and 5. We have a 3, 4, and 5 from Wayne, number 4 from Mark. We got number 2 and 4 from James. So we're getting lots of 3s, 4s, and 5s.
And I think we agree. And one of the most important parts when I work with teachers is they tell me that the practices are different ways to teach. I think that's true, but they're also something that we want to make sure that the students know that are there and that they know we're going to expect them to distribute their ideas and to demonstrate these different practices. So, Jennifer?
All right. So we are, thank you for helping us think through that. I like thinking with my students about which practices they're using, and I'm going to tell you a little bit more about that later in the webinar. We're going to move to our second task of the evening. And so I'm going to tell you a little bit about using this task with my students. My geometry students we're currently in a unit on geometric measure and dimension. So last week I gave my students the first part of the Infinity Pizza task that is in the Great Tasks 6 through 12 book. The students are asked to create a fair method for cutting any triangular pizza into 3 equal-sized pieces. I asked students, like I asked you tonight, to work alone for just a few minutes before they started sharing what they were doing with others on their team. I find myself more and more deliberately asking them to providing them time to think alone first before they jump right into talking with each other, so that even the person who is quiet or even the person who takes a little bit longer to think through how this task might play out has a little bit of time to do that. So while they were working alone, I walked around and watched what they were doing. Many of the students started on paper, but they also had a TI-Nspire document that they could use, and I'll show you that part in just a minute. And so a few of the pictures that I saw, I kind of liked this progression of a student who was working alone at first, and she just kind of went through a couple of different things you can do. And I saw somebody who said they might start with an equilateral triangle, and you're absolutely right. A lot of students did. Hers, I guess, probably looks a little bit more isosceles than that. But many of them started. But because of our work together throughout the year, they recognized that even though they might have started with an equilateral triangle, they needed to get to the point where they were examining what was happening with other triangles as well. And it's clear about that in the task too. It says for any triangular pizza, so they're beginning to pay attention to those words. Another student, I had to show you, of course, decorated her pizza with pepperoni. you know, that you can see too up here. She's beginning to think about, you know, where might some point be here in the middle of the pizza where we might be able to divide that pizza into 3 pieces that have equal area. So my students and I use TI-Nspire Navigator to help manage our classroom. I took a class capture to see what students were doing on their handhelds. So you can see here my different students, and you can see that some of them are still on the title page, and that's because those students were working on paper. So everybody, they weren't required to move to the technology. It was their choice of what they wanted to do. Last year, I read Smith and Stein's 5 Practices for Orchestrating Productive Mathematical Discussions. We're just going to go through those very briefly here. But the practices for teachers are to anticipate how students will respond to a task. We've already talked a little bit about that tonight. One of the nice things about the Great Task books is it gives you some idea of how students are going to respond because it provides some of that student work, although you still need to work through the task yourself, or at least I find that I need to work through the task myself so that I, you know, kind of know how would I work this and begin to think about how my students might do that. While students are working on the task, you are monitoring their work, and that's what I was doing, walking around with my iPad to take a few pictures, and then also using my TI-Nspire Navigator software to take a class capture of what students were doing on their handheld. And so you monitor the student work so that you can select which student work should come out in a whole class discussion. And then you sequence that student work so that students will ultimately be able to connect the mathematics and the different solutions. So I've started learning about this. It's probably been 1.5 years now, maybe 2 years. And this idea of sequencing, I think, as teachers is something that we've always done, but we have not necessarily known that we've done it. When we call on students, we don't always call on them randomly. I know that we do sometimes, but we often will have, call on one student in particular first, and then another student to follow up with something, that follows from the first student's work. And so, but now that I know about these 5 practices for teachers, I'm a lot more deliberate in how I do this in the classroom. And so I pay a lot more attention to sequencing than I did in the past when I was, kind of randomly doing it and not realizing that I was. So this is the second class capture that I took. You can see up here the auto refresh is off, but I could set that to update every 30 seconds, or I can just click on the refresh button manually to update. And so I want you to look at the student work for just a minute. Actually, it won't be a minute, it'll be about 30 seconds. And I want you to think, look, and see whose work might you choose to discuss first if you were going to lead the class discussion. Whose work might you start?
And Jennifer, while they're doing that, maybe you can answer a quick question.
Okay.
Nancy wanted to know if this task was from the Math Ed Leadership.
So the task is in the Great Tasks book. It's not one that's linked on the site at NCSM. The Math Ed Leadership site is the NCSM site, and it's not linked there, but it will be available tonight in the downloads. So you'll get access to the PDF of this task at the end of the webinar.
Thanks.
Mm-hmm.
And so far it looks like
we got Eli and Reagan.
Yep, I saw maybe a Caitlin, then Eli.
Okay. Well, this is kind of exciting because those are some of the ones that I chose. But I did, and I saw at least one person say that you might start with Alex. And Alex is who I started with. Okay, let me think of where I'm going to go. So this is a close-up of what Alex did. So Alex talked about his work. We made his picture big on the screen, the projector at the front of the room, so that everyone could see. And I just asked Alex to tell us a little bit about his work. He proceeded to tell us that he joined the midpoints together and ended up creating a pizza with 4 equal slices instead of 3. So Alex answered a different question. It wasn't the question we set out to answer, but it was a good question nonetheless, and he gave us some good mathematics to remember about the triangle formed by the mid-segments. And so we celebrate diversions like that in my classroom instead of, trying to change them to be something that they're not. We celebrated that, and then we started beginning to think about what we could do to get our 3 equal sizes. Next, I moved to Kristen. So Kristen was actually in the process of trying to trisect the angle. Trisect was not a word that my students, with which they were familiar. We thought about what a word might mean if you were going to cut an angle into 3 congruent angles. And so they were kind of proud of themselves for thinking about that. And, of course, then wanted to think about what would it mean if we cut an angle into 4 congruent parts and 5 congruent parts and so on. But Kristen, you can see, while she has started thinking about trisecting this angle, she has not begun to think about the actual areas of the triangles that are formed and whether those triangular pieces were equal in size. Next, we moved to Reagan. And so you can see from this picture that Reagan has come up with something that appears to work, right? She has equal area for those triangles. And so I'm actually going to move to Reagan's work. I have her file from class that I collected at the end. I'm going to go ahead and make this a little bit bigger. And so I made Reagan the live presenter. And so that meant that whatever Reagan was doing on her handheld, we were seeing at the front of the ring, kind of like you're seeing this at the front of the ring now. So I had asked Reagan to change her triangle so that we could verify that what she had done wasn't just working for that one triangle, but that it was continuing to work. And so Reagan started talking about what she had done. And this was it was neat because this reviewed a lot of information while, our unit was on area. We were using language that we had been talking about really since the second unit of our course, when we had done a constructions unit and thought about medians and centers of triangles then. So they were having to come back with that, this is the median, and that point right there, that balancing point is the centroid. And so one of the other things that I liked about Reagan's is that she had hidden some of her work from us. So when we really began to think about why those 3 triangles had equal area, it was important for us to think about what was true about these 2 triangles and these 2 triangles and the triangle that is kind of on the whole right side of the big figure and on the whole left side. And so it was through that we were able to come up with the reasoning behind why Reagan's method was working. So I called on another student to share their work after Reagan. I went back to some of the ones that I had seen on paper, and these were, of course, while some other students were working, on their handhelds, those who were still on paper had more than initially. So I wanted to show this picture because I thought this was really interesting. Flint had thought about using the centroid. You can see his explanation up here in his brief picture here. You can also see that he was really trying, even on paper, to do different types of triangles and not, just stick to an equilateral triangle. But what I really love about this is that in our last unit, we did a unit on coordinate geometry. Well, one of the Common Core standards for geometry talks about partitioning a directed line segment into a given ratio. And that is just language that is new for me. I haven't used that language. I've been teaching geometry for 21 years, and we haven't talked about partitioning. We haven't even talked about the fact before that a midpoint partitions a segment into a 1-to-1 ratio. And so I love this new language that Common Core is giving us to use and to think about more deeply. And so he said that he wanted to partition the base into 3 equal parts and then connect the vertex to the points. And I have other students who explain why that works. And so we'll move to that. I had another student. Yes.
Sorry to interrupt. We had a good question that I think you might be able to answer.
Okay.
Julie asked that you had already taught centroids, and how long after that lesson was this activity?
Oh, the centroid stuff, we actually did that back in September. That was our second unit, but our area and volume unit is later. So it's just that this kind of all, comes back to, and we've actually used a lot of that in several units throughout the course. But yeah, it's definitely been a while since we went through medians and altitudes and perpendicular bisectors, angle bisectors, since we went through those in detail. So yeah, it had been a while. Okay, so what we're seeing next is Benny's work, and Benny has his set up a little bit more like here's a reason, but I loved too on his paper that he says partition one segment into a 1-to-1-to-1 ratio, and then he tells us what those points are and shows that. So I had asked Benny, after Reagan showed us her work, I asked Benny to come up to the board and show what he did to the class. And so Benny presented his work. He showed this here, and he's saying that X and X and X, those all have the same area, and he talked about why that was the case. You can see he's drawn his altitude in, which is the height for each one of the triangles. And so then someone asked, well, is that going to work if you do it to a different base? And so immediately Benny says, yes, that's going to work for a different base, but whoever it was wanted to be shown. So we, with our interactive whiteboard, copied the figure and moved it, and even though he was drawing to a different base, Benny insisted that we rotate the triangle because he still wanted his other base to be on the bottom. He wanted it to be that horizontal segment. And so he has that drawn in, and he has his altitude drawn in as well. He was trying to use this left side here for his altitude, and we decided we would not buy that because that just did not look perpendicular to us. So then he went back in and drew his altitude, and again talked about why those three are going to have equal area. So next, you can see Caitlin's work, and so Caitlin was using the same method as Benny, but she was on her technology. And you can see here with her measurements that she was getting these points to the point where they were going to be equal in area. I think I have Caitlin's work to share here. But her work wasn't constructed, right? It breaks when we grab and move a point. Those segments are no longer, those areas are no longer equal to each other. So that's what we spend really our whole year in geometry learning about. What's the difference here between just drawing this and and really constructing it. And our technology begins to help us make sense of that. So there is a part 2 to the Infinity Pizza, and actually this is the reason that it has the name Infinity Pizza. It has something here about a sequence and thinking about whether the sequence converges, and it's an absolutely great exploration. I will have to admit I haven't had time to do this part with my students yet, but I'm finding this is our second year of teaching a Common Core geometry class, and I'm getting to do more this year than we got to do last year, and so I know next year we'll get to do even more. So my goal for my students is not just to provide them opportunities for them to learn the content standards and use the math practices while they're working on a task, but I really want them to begin to recognize when they are using the practices. I gave my students a list of the practices along with a short explanation of each practice at the beginning of the year. We had that list posted on posters in the front center of the room. This language has become part of how we talk to each other about what we're doing in class and what our goals are for learning in each unit. Which math practice would you expect to see your students demonstrate with the Infinity Pizza task? I'll give you just a few seconds to think about that and answer. I think I have a list of the practices on the next slide for you. And then I'm going to share with you a couple of reflections from my students. So what standard for mathematical practice would you expect them to use in that Infinity Pizza task? So I'm saying make sense of problems and persevere in solving them, another model with mathematics, use appropriate tools strategically. Looks like we're hitting them all at different points. Even that look for make use of structure. Yes. Expressing regularity and repeated reasoning, paying attention to whether that's happening in all of the different types of triangles or in just one of those. Okay. So I sent my students a Google form for them to reflect on which math practice they felt like they used the most in this. And so I'm not going to read every bit of this to you, but I'm going to tell you just a little bit about what they said. So AK said, in this challenge, we used many of the math practices, but the one that sticks out to me is construct viable arguments and critique the reasoning of others. I think this was the most prominent because of the way each student was given the opportunity to share their solutions, and the class in turn was given the opportunity to compare and support that student's method or argue for a different approach. Either way, it provoked in-depth thoughts to look beyond the simple, find the solution, and move on to the next problem. Katie noted, I chose reason abstractly. Go to this next one. I chose reason abstractly and quantitatively because when you have a problem like this, it's easier to look at numbers in general terms. I first had to think about the question. It was hard trying to think of where to start. So I thought about cutting the pizza with the lines connecting the midpoints together. This would have worked had the quadrilateral, these lines made a square, but it wasn't because I was using a right triangle. So next, I went to look at the lines of medians. Well, the area for each triangle then was not equal. This was trying my patience, but I kept going. I then looked at the circumcenter and the lines containing that, but it ended up just like the first one. I had 3 triangles and a quadrilateral, which was 4 pieces that definitely did not have the same area. Then I thought for a few minutes. It dawned on me that we were dealing with area, and the formula for the area of a triangle is half base times height. So I thought, how can I get 3 triangles from one where the base and the height never change? I used 21 for my base of the triangle because 3 will go into 21 7 times. I had 3 triangles with a base of 7, and the height couldn't possibly be different because they all came from the same triangle. I think I messed up on which slide I was on. But I think it's really important for students to think about what they've done, and I think it's really insightful for us as teachers to get to hear some of these responses. Like, it's a big deal for Katie to reflect on the fact that this was hard. What I tried first didn't work, but I tried something else because we've been trying something else all year long. These students didn't come into my classroom ready to try something else. We have learned. We have persevered. We have practiced trying something else. Another one, Chandler talked about, he felt that modeling with mathematics, because the entire goal was to use a certain math practice and determine how to evenly split a pizza. He talked about the centroid being the central point of the point of central mass and searching for the centroid. Then he says, note, this was conducted on an equilateral triangle. Next, to elaborate, I tried the same procedure on an isosceles triangle and then a scalene triangle. The results were conclusive. My method was feasible for any triangle despite any side length differences, even if the piece of sides were of different lengths. Kelsey says, in this activity, you had to construct viable arguments and critique the reasoning of others the most. The reason I say this is because you had to come up with a way to split the pizza into 3 equal slices, and you had to persuade the class that your reason worked every time. Also, you had to listen to other people reason why and critique if their answer was wrong or right. Rosalind chose make sense of problems and persevere in solving them. In order for us to solve this problem, we had to have perseverance. This wasn't a problem where the answer took a minute or 2 to solve. It took us a good portion of the class period to construct our argument. It also took many approaches. We didn't get a good answer the first try. It took a while to make sense of the problem, and we had to persevere in solving it. Again, I think it's a big deal for students to recognize that we're going to give them problems that are difficult, that are challenging, and we want them to persevere in solving them. And then I had to include Ani, who wrote this last reflection. Ani has been speaking English now for about 6 months, and she writes a beautiful reflection about how she thinks that this is modeling with mathematics and why it worked to have the base cut into 3 equal parts and the height. So real quick, I saw Travis ask where students did this. I made it just a quick Google form, and I sent that out to them. So they were able to do a drop down to choose which standard of mathematical practice they used the most, and then I just did a paragraph text question for them to write their reflection. And it was the first time I've done it with a Google Doc. I've done it in the past where they will send me an email or they'll write a reflection and turn it in, but I really liked the Google Doc. So I've actually gone back to it and edited it to include like the task name, and I plan to continue using it because I think this is a great way to capture. And I think they enjoyed typing it into a form. I think that was more fun for some of them. So we're going to go back to Connie now, and she's going to tell us about our final task for the evening.
Actually, before we do that, I think we have one really good question from Wayne that maybe you could answer, Jennifer. He said he really liked the writing component. He wanted to know if students came in expecting this, or was it somewhat of a shock the first time they were asked to do it?
About the writing? I don't know if they were shocked. I guess because we have a lot of writing across the curriculum. I don't know the right word to use, but you know, they're trying to get us to do that in every class. So I think students, you know, recognize we're going to have to write in all of our classes. And then the other thing is, you know, it really, it's not like I'm looking for a book, and if you do it on just, you know, kind of one particular task. What I've done in the past is just over the 9 weeks, I ask them to send me 1 or 2 reflections, and they can choose the task. For this, I specifically asked about the Infinity Pizza task because I wanted to get some reflections to be able to share with you. But anyway, I think it's good for them, I guess, even if it takes them a while to get used to it.
So as we look at the last one, we're running out of time, and it's just great to see how the students respond to the practices and how a great teacher actually uses a task and to look at the students' work. The goal of an open-ended question is to learn more about what students know rather than what they don't know, and that's what we tried to do with the tasks themselves. But actually what you get out of them is what the teacher, how they use them and what they put into it. In a quadratic smile, this is just the launch, and one of the things I even see when students get to me in college after even being successful in high school is they don't understand a quadratic. They think it's something we make up just to torture them. And they don't look for the application of it. It's just something in a textbook. And so we started out with our launch to have them look for real-world examples. And yes, it would be difficult in a classroom or in the hallways or in a building to always find exactly what you wanted, so we also included in the internet as a possibility and to work on their language and vocabulary associated with quadratics. The last part of the task is the one we're going to focus on, and this is not really so unusual for what people do in the classroom with their students. I'm creating a picture, but one of the things we want to do with the task is if you're going to find out what they know, you have to have some criteria rather than just say create a picture. We wanted them to model the different components of a graph and to be able to tell us where those were in their picture. So that was the part of the great task that we were very specific about. Jennifer?
So I'm sure that many of you have done something similar with your students where they have created some kind of task, you know, using some kind of graphing software or graphing handheld. But I just thought I would share a couple of these from our Algebra 2 teacher. So she has students create a drawing on their handheld, and they are using piecewise functions, and they do have some requirements about, you know, a certain number have to be trigonometric, a certain number have to be quadratic, you know, different things that I'm going to look up here in the graph. You can see the different functions, but it gives them a great understanding of piecewise functions when they're creating their own here. So this was one that Madhu created, another one here by Marjorie. And she, of course, has a lot of quadratics in there. You can see those with the eyebrows. And then another one by design. He's one of our award-winning band students, and so this is his passion. This is what he wanted to spend his math class creating as well. And so created that image of his trumpet. And then my own daughter's favorite from Shreya, which is, of course, Harry Potter. So I just wanted to share a few of those with you because, you know, thinking about the way the task is written, and, you know, at the beginning of a unit on quadratics, you might want them to have these specific quadratics where they are, you know, showing that axis of symmetry and the different things that were there in the task. And then, you know, by the end of the course, you might want them to put more of that together and use a multitude of functions.
Now, this slide, we wanted to have you think about your tasks, and we're not going to have a lot of time to get your input on this, but think about the criteria for a great task and what are you doing in your classroom that already fits into some of these. It's important that the students actually have the opportunity to participate in tasks and not just go with the old practice, show, practice, show, practice. It doesn't give them the opportunity to demonstrate what they know. And if you have some great things you want to share, go ahead and add those in the chat as we get ready to close this up. I want to close with a quote from Steve Limewon. It was at a conference where I was summing up the day, and one of the things he said, which has resonated with me, is people won't do what they cannot envision. People can't do what they do not understand. People can't do what's not practiced, but practice without feedback results in little change, and work without collaboration is not sustaining. So we hope that you've gotten some ideas here, and they'll motivate you to find tasks with your students that allow them to demonstrate what they know instead of a traditional exam where we find out what they don't know. I'm going to toss this back to Mike.
Thanks so much. So as I begin to wrap things up, I'm sorry, Connie, are you, you're good?
Yep.
Great. So as I begin to wrap things up, again, as Connie mentioned, if you do have any last-minute questions or comments, please feel free to use that chat window, or if you have a question, use the Q&A window. I know Jennifer and Connie are going to try and get those questions answered live. We do want to share a few resources that we have available on our website for those that are especially new to the technology. And our website is education.ti.com. And one of the first resources I would share with you is under the Professional Development tab. Scroll down to Online Learning. And then one of my favorite places to go there, if I forget how to do something or if I'm new to the technology, is I go to Tutorials on the left-hand side. So what we have here is some links for some Atomic Learning tutorials. So our friends over at Atomic Learning have created some really short, free video tutorials. It looks like here for TI-Nspire, and then the TI-83, TI-84 Plus. And so just to show you what that would look like, if I click on maybe the Atomic Learning tutorials for TI-Nspire apps for iPad. So you can see some really short videos on how-tos with that technology. And also I noticed that there was also Atomic Learning tutorials for TI-Nspire Navigator, which Jennifer mentioned she uses in her classroom pretty extensively. Also under the Professional Development tab, check out the PD in your area. So we're really excited about this. On the left-hand side, you can look at the T-Cube summer workshops. And feel free to scroll through on your own time at your own pace. But all these workshops are focused on a certain technology and a certain content. They range from anywhere from 1 day to 3 days, and we have over 50 locations across the United States. So please feel free to check that out. Registration is live, and these are really taught by top-notch instructors like for instance, Jennifer, I think, has taught these in the past. So please feel free to take a look through and see if there's anything that matches some of your needs. For those that haven't heard yet, we have a really new initiative and program that we've released called STEM Behind Hollywood. And STEM Behind Hollywood is an exciting new program created by TI with the assistance of the Science and Entertainment Exchange. And that's a program of National Academy of Sciences. The goal is to really get students excited about STEM education and careers. And so we brought in scientists and experts who consult on Hollywood films and TV. And they worked alongside with leading math and science educators to create free classroom activities for TI technology. These activities center around the math and science behind Hollywood themes like zombies, superheroes, space, and forensics. And I think earlier I noticed that Mark had used the chat window to mention that he had just downloaded the zombies activities and be checking out tomorrow. So please feel free to learn more at stemhollywood.com. TI is now on TeacherTube, which is an online community for instructional videos that is educationally focused and safe for teachers, schools, and students. It also approved for viewing from within school networks. Feel free to watch more information on solutions, tutorials, webinars, and all of that can be found on our TeacherTube site. We do have some upcoming webinars that we'd like to share with you. We really are excited to sort of begin finishing out our spring series, but please know that we will be creating additional webinars for the fall for sure. We really hope you'll keep the conversation going on one of the many social media networks that we use. So if you like what we talked tonight, feel free to ask questions or offer comments on any of their social media networks.